I hope my screen is visible to everyone.
Yes, ma'am, it is.
Okay. So meanwhile, the others will join. I'll start with the brief introduction, and Sampath will be clear, and you people can answer Yukta and Pranav. Can anyone amongst you tell me what do you understand by what matter is?
Ma'am, can I answer? Matter is anything which occupies space and has mass.
So there are two conditions for anything to be matter: that it should occupy space and has mass. Fine. The next, Pranav, can you tell me, is there any scope which is like by which we can relate the matter to the sense organs? Is there any relationship between the sense organs and the state and the matter? Pranav?
Mom,
Yes.
can you repeat?
I'm asking, is there any scope that we say that the sense organs are related to matter in any way?
No, mom.
No. Okay. Good evening, Jitendra.
Good evening, ma'am.
Beta, can you think of the question I'm asking? I'm asking if we can relate the sense organs with the matter in any way. Did I say anything like this in the last class? We can sense the matter with our sense organs. This I had explained in the last class, if you all remember. So these are the main conditions which tell us whether a given substance would be matter or not. And in the last class, we had taken up a few examples. So, first I give the definition of matter, that anything that occupies space and has mass is matter. It can be felt by any of our five senses. Then ancient Indian philosophers said that all matter, whether living or non-living, is made up of five basic constituents which are known as Panch Tattva. And these are air, fire, earth, sky, and water. So these are the five things. Then we discussed about a few substances, if we can consider them as matter or not, right? So I had given some questions as homework. We are going to discuss those questions, and then we are going to move further. Hmm. Just a second. So I'll open in the app only. Oh, I wrote it as it is. That's why I was thinking why I'm unable to get it. Okay, so who is going to tell me the question which was there, which all, I think 10 examples I gave. We'll start with the first one. Tell me. Yukta, tell me the first question. What was it?
Ma'am, air.
Air. So what do you think? Is it matter or not?
Yes, ma'am, it's matter.
Jitendra, can you tell me the second question of the homework? Jitendra? Jitendra, are you able to hear me?
Yes, ma'am.
What was the second question of the homework?
Heart, ma'am.
HEART was the question.
Yes, ma'am.
So what do you think? Is it matter or not?
Yes, ma'am. It is matter.
Pranav, what about the third question?
Book, mom.
Book. So what do you think of the book? Is it matter or not?
Yes, mom. I think.
Can you tell me the next question also so that I can ask Sampath the question?
Flower, ma'am.
Flower?
Yes, mom.
Okay. Sampath, do you think flower is a matter or not? Yes, it is matter. Yukta, can you tell me the next question?
Feelings.
So what do you think, Yukta? Is it matter or not?
Ma'am, it's not matter.
Not matter. Jitendra, what about the next question?
Water, ma'am.
Water. So what do you think? Is it matter or not?
Yes, ma'am.
It does. It is matter because it occupies space and it has mass also. Okay. Next question, Pranav.
Clothes, ma'am.
Sorry?
Clothes.
Clothes. Okay. So what do you think? Is it matter or not?
Yes, ma'am. Matter.
It is. Next question. Can you tell me the next question also?
Flying kites, ma'am. Flying kites.
Flying kites.
Yes, ma'am.
Okay. Sampath, do you think the kite is matter or not?
Ma'am, kites are matter, ma'am.
Flying matter?
No, ma'am.
No. Flying is not matter. So we have to look if anything is matter or not. So if we talk about flying kites together, it is not matter because flying is not matter. But kites, if we consider, then it is matter. Okay? Yukta, next.
Yes, ma'am. Ma'am, it's juice.
What do you think of juice?
Ma'am, it's matter.
Yes. And Jitendra, can you tell me the last question? I think that's the last which I gave as homework.
Hair, ma'am.
What is the question?
Hair.
Hair.
Yes, ma'am.
What do you think? Is it matter or not?
It is matter, ma'am.
I hope the term matter is clear to everyone.
Yes, ma'am.
Okay. So now let us come to the properties of matter. First and foremost thing, the basics which you should know that the just a second here. That the matter is mainly of three types: solid, liquid, and gases, about which we are going to study in this chapter later on in detail. Fine. So, the first property or the first thing which we need to know is that matter is made up of particles. Is made up of particles. This I started in the last class, right? Now, what are particles? Particles are basically either atoms or molecules. And what are molecules actually? Molecules are the substances which are formed when atoms combine together. When same or different atoms come together, they form molecules. Clear, everyone? That when come together, they form molecules. So particles are made up of matter. How are we going to prove this? So for this, we have an activity. I will first explain you this activity, then we will see this activity, and then we will move further. Fine. So what happens is, if we take a glass at the home and take 100 ml water in it. In this 100 ml of water, if I add 20 drops of blue ink, then what are we going to observe? That the entire 100 ml of water becomes blue? Yes? Now what happens is, if we have to if we take the another glass of water, and in this glass of water, now I am taking 90 ml of clean water, and if I add 10 ml of, I'll name it as glass 1. Fine, I'll name it as glass 1. So if I add 10 ml of water from glass 1, then what are we going to observe? It was all blue in color, the entire 100 ml. If we take the 10 ml from here, that means we're taking the blue water from this one, right? So if we add this into it, then what are we going to observe? This also will acquire some blue color. Acquires blue color. Similarly, if I take another glass, and in this glass, again I take 90 ml of water, and then again I tend to add 10 ml of, now this would be glass 2, the second one, fine. So if I add 10 ml of water from glass 2 now you people tell me what are you going to observe? The color will be,
Ma'am is very slight.
sorry,
Ma'am, very slight bluish color.
yes, slight blue color will be still observed. And if we keep on doing this n number of times, if we keep on doing this, adding the water from the previous beaker to the new beaker, then what we will observe, we are going to observe the light blue color till a lot of beakers. Means taking just 10 ml of the water which we had taken initially, then transferring the water from the second beaker, then to the third beaker, then to the next beaker. This shows us that the blue ink particles, they were so small and those got transferred again and again and again and again, which showed us that the particles of the ink were very, 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 very small. Clear? All four of you doubts, children? Okay. Now we are going to see this activity. Okay, before I show you the activity, first I'll explain you what you're going to see in the activity. In the activity, instead of ink, in this I told you about ink because you could easily relate to the ink because you know how the ink looks, what happens when the ink mixes in water. Now the activity which we are going to see will involve potassium permanganate. Manganate. So the formula of potassium permanganate is KMnO4 and it is purple in color. So we are going to observe the activity and we are going to see in many beakers this purple color initially is very dark. Then later it becomes a little light, then a little more light and a little more light, and it keeps on happening till a lot of beakers. Means you can imagine that maybe 10 grams of this salt will color at least 1 liter of water, even more than that. So you can imagine only 1 or 10 grams of this salt colors around 1000 ml of the water. Oh, sorry, 1000 ml of the water. Clear, everyone? Can I show you the activity now?
Yes, ma'am.
Okay, let's go ahead and see. This activity is there in the NCRT also. I'll have to see if it is Hindi or English. If it is English, then we can go ahead.
For class 8, 9.
I'm going to take a very small quantity of potassium permanganate crystals and we are going to dissolve it in 100 ml of water here.
See the color, you can observe it is dark purple. Right?
Can you see that deep purple color? Now if we can show that a very small quantity of potassium permanganate can also color a large volume of water, then that means that these crystals must be containing millions and millions of particles that get spread on dissolving and color the water. So the particles of potassium permanganate must be very, very small. But the trick we are going to do is, rather than dissolve a small quantity of potassium permanganate in a large volume of water, we are going to make use of the purple water here. So we are going to take a small quantity of this purple water and dilute it with more water. And then again take a small quantity of that and further dilute it with more water. It's the same effect as adding a small quantity of this in a large volume of water. Let me show you how. First, I have taken 1/10 of this purple potassium permanganate solution in the small beaker here. So 1/10 of 100 ml is, as you can see, 10 ml. Now I am going to pour this solution into the empty glass here, and then we are going to dilute it with 90 ml of water so that the total solution becomes 100 ml. So can you see the light purple color now? Now let's take 1/10 of this new solution and again dilute it with water to make the total volume 100 ml. Again, we have taken 10 ml of this light purple solution and we are going to dilute it with water again. So the total volume of the new solution is 100 ml. And can you see the pink color of the solution? And again, we are going to repeat the dilution process with this new solution. So even in this last glass, can you see that that light pink color is still visible here? So this process of taking a small part of the colored solution and repeatedly diluting it makes the color go from dark to light. With the help of this experiment, we've shown that if you take the same small quantity of potassium permanganate and put it in a large volume of water, you're going to end up with a light pink color like this last glass here. So what's our conclusion? These tiny crystals of potassium permanganate must be containing millions and millions of potassium permanganate particles, which on dissolving in water, they can spread through the large volume of water and give it a light pink color like this. So the particles of matter must be very, very small.
Here's how to play that song for the holidays. Put your
I hope the video was clear.
Yes, ma'am.
So this is what we perform in the class also. Fine. So you have seen it. Now we are going to read the NCRT till this point and later we are going to move further. Fine, children?
Yes,
Okay,
ma'am.
now the next property. I hope in everyone's school the main book is NCRT only.
Yes, ma'am.
Okay, good. So we are going to start and I have already explained you till this point only. So first we are going to read till this point and then later I will explain you and then we will do. Okay, so one child will read one paragraph. We can start from Yukta and then later I can tell where to stop. Okay.
Ma'am,
Yes.
I'm sure you start reading.
Yes, yes. Please start.
As we look at our surroundings, we see a large variety of things with different shapes, sizes, and textures. Everything in this universe is made up of materials which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, planets, plants, and animals, even a small drop of water or a particle of sand. Everything is matter. We can also see as we look around that all the things mentioned above occupy space and have mass. In other words, they have both mass and volume. Since early times, human beings have been trying to understand their
Okay, you can stop. Till this point, any doubt, children? Okay.
No, ma'am.
Sampath, you can start reading.
Since early times, human beings have been trying to understand their surroundings. Early Indian philosophers classified matter in the form of five basic elements: the Panch Tattva, air, earth, fire, sky, and water. According to them, everything, living or non-living, was made up of these five basic elements. Ancient Greek philosophers had arrived at a similar classification of matter. Modern day scientists have evolved two types of classification of matter based on their physical properties and chemical nature. In this chapter, we shall learn about matter based on physical properties. Chemical aspects of matter will be taken up in subsequent chapters.
So you should all know about the five Panchatattva. I have already discussed air, earth, fire, sky, and water. Okay, Jitendra, can you start reading physical nature of matter?
Yes, ma'am.
Yes, please go ahead.
For a long time, two schools of thought prevailed regarding the nature of matter. One school believed matter to be continuous like a block of wood, whereas other thought that matter was made up of particles like sand. Let us perform an activity to decide about the nature of matter. Is it continuous or particle?
Particulate. So I had given this example in the previous class that this was there were two theories which came up. Initially, it was believed that the particles may be continuous or the particles may be the matter may be continuous or made up of particles. The matter may be continuous or made up of particles. So, what example I took so as to make you understand about both the things was that what if you look at a glass, here, the spectacle glass or a normal glass, think of any glass. So, what do you think by looking at it? You think that it is a continuous substance like a block of wood, also, or a glass. But if we drop that glass, then what happens? The glass breaks down, and the glass breaks down to give us very small particles, right? So it was considered that the particles are continuous, but no, they were not sorry, the matter was continuous, but no, it was concluded that it is not continuous, but the matter is made up of small particles. Clear? Now we are going to read the activity also, which is present in the NCRT. Then we will move further. So, who was reading? Jitendra? Pranav, you can read the activity and you can read before this how small are these particles of matter. Before that, you can read everything. Activity also.
Yes, ma'am. Activity 1.1. Take a 100 ml beaker, fill half of the beaker with water and mark the level of water. Dissolve some salt or sugar with the help of a glass rod. Observe any change in water level. What do you think has happened to the salt? Where does it disappear? Does the level of water change? In order to answer these questions, we need to use the idea that matter is made up of particles. What was there in the spoon, salt or sugar, has now spread throughout water. This is illustrated in figure 1.2.
So, what actually happens is that if at all we put some salt or sugar in the water, do we observe it after some time? No,
No.
what actually happens is either it is salt or sugar, doesn't matter. It goes into the space of the water. So it occupies the space of the water which is available. And this, if you look at this picture, this shows that the particles of water which are magnified millions times, that is why you are able to see them. Otherwise, they are so small that you cannot see them with your naked eyes. And when the salt was added, after some time, whatever space was available in water, you can look at the picture that within the water molecules we are able to observe the small salt particles, right? So when we dissolve salt in water, the particles of salt get into the spaces between the particles of water. Clear? So basically the matter is made up of particles which have the tendency to go inside each other depending on how much space is available to what kind of matter. Okay, let us read further. Yukta, are you there?
Yes, ma'am.
You can start reading the activity. How small are these particles of matter?
Um, Take 2-3 crystals of potassium permanganate and dissolve them in 100 ml of water. Take out approximately 10 ml of this solution and put it into 90 ml of clear water. Take out 10 ml of the solution and put it into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Is the water still colored?
So what is the answer? First of all, tell me, is the water still colored or not colored?
Yes, ma'am, it is.
It is colored, and you can see this in the picture also.
Yes, ma'am.
Okay, let's read further now. Sampath, you can read further. This experiment shows.
This experiment shows that just a few crystals of potassium permanganate can color a large volume of water, about 1000 liters. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. The same activity can be done using 2 ml of Dettol instead of potassium permanganate. The smell can be detected even on repeated dilution.
Yes. So if you ever use it all, you must be aware that it has a characteristic smell. So if you keep on doing the same thing with Dettol, then the smell of the Dettol will keep on persisting even if we keep on diluting the solution as many times. Clear? So two main important things I have just told you. The first thing is that the matter is made up of particles. Fine. So we know the activity to solve this. And secondly, the particles of matter are very small in size. Are very small in size. Is it clear? Now we are going to study about the characteristics of matter. So the first characteristics I'll explain you today, and then we will see a small video for that. Characteristics of characteristics of particles of matter. Now this was about the characteristic or property of the matter. This was characteristics of matter too. Now we are going to see the characteristics of particles of matter. It's very easy and very interesting. Everything you can relate with your everyday life. So before I write anything, I would just like to ask or repeat the same example which we have just read in NCRT. If I take a spoonful of salt and put it in a glass of water, what are you going to observe?
Ma'am, salt solution, it gets dissolved in the water.
The salt gets dissolved, and if you try to sip that water, you will be able to feel the taste of the salt, right?
Yes, ma'am.
So, the first property is that the particles of matter have spaces between them. If there were no spaces, then the salt would not have disappeared, right? Yes or no? Good
Yes,
evening,
ma'am.
Ashra.
Good evening, ma'am. Actually, I did not join because I had some problem with my tab. It's in repair. So I had to join with my laptop. It took a little while.
No problem, dear. I have just explained them about the characteristics of matter and that the matter
Yeah,
is made up of particles and
okay.
the particles are very, very small in size. We have seen a video related to these 2 points. Right now, we are moving on to the new topic, which is the characteristics of particles of matter. The first only we have just discussed that the particles of matters have spaces between them. Again, here, can I take the example of the ink? Yeah.
Yes, ma'am.
A few
Yes,
drops
ma'am.
of ink in the water, then what are we going to observe? It mixes. Why it mixes? Because there were spaces. If there were no spaces, they wouldn't have mixed. Another example I would like to give it to you. If I take some honey and put it in the water, or not in the water now, in the milk, then what are you going to observe?
Ma'am, the honey settles down in the milk, but if you keep it for a while, then it will like dissolve in the milk.
Ultimately, what are we going to observe? That they get mixed with each other, right? So this shows us that the particles of matters have spaces between them. Now we will just quickly see a short video to see the first characteristic, then we will move further. Fine. Particles of matter have spaces between them. Okay, again we will see this video only because the previous one was good. So you can go ahead and see this one.
इनकी गवर्नमेंट एग्जाम प्रिपरेशन की गाड़ी
I'm going to immerse this spoon into this glass of water, and you carefully observe what happens to the level of water. As you can see, the water level rises a bit. The rise in water level is going to be much more clear if you use a larger object. Now I'm going to put the sugar grains in water, and you carefully observe what happens to the level of water. We are going to dissolve this sugar in water. Once we stop stirring, as you can see, there is no rise in the level of water. Why is it so? It's because these sugar grains break up into tiny sugar particles when they are dissolved in water. And these tiny sugar particles go and occupy the spaces between the water molecules. That's why the level of water does not show a rise. So this experiment proves that particles of matter have spaces between them. Now let's visualize this scenario. So imagine we zoom into this glass of water a million times. So how is it going to look? It'll probably look something like this. These white balls here represent the water molecules. And when we put the sugar grains into water, each and every sugar grain is going to look like this gigantic ball compared to these tiny water molecules. So let me put this sugar grain into water. Watch carefully, because this huge sugar grain is going to soon break up into tiny sugar particles, represented by these tiny red balls. As you can see, these tiny sugar particles go and occupy the space between the water molecules.
So I hope this was clear, that the particles of matter have spaces between them, and we could easily see that if we put whatever we put, first it breaks down, only then it takes the space which is available to it, right? Let us read the
Yes,
same,
ma'am.
and then we are going to move to the next activity. It's a small one only. So Aksha, since you've joined now, you can read it. The characteristics of particles of matter, the first one.
Okay, ma'am. May I read now?
Yes.
Ma'am, may I read now?
Yes, you can read now.
Characteristics of particles of matter. Particles of matter have space between them. In activities 1.1 and 1.2, we saw that particles of sugar, salt, Dettol, or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee, or lemonade, nimbu pan, particles of one type of matter get into the spaces between particles of the other. This shows that there is enough space between particles of matter.
Yes. Now only I will give you the introduction of the next property, and then we are going to see and discuss more about it in the next class. So the next one is that the particles of matter are continuously moving, because we have a lot to discuss in this property, so we are going to discuss it later. So how can we say that the particles of matter are continuously moving? When I asked about milk and honey, what did Akshna answer? She told that, ma'am, initially honey is going to settle at the bottom, and if we leave it for some time, we are going to observe that it gets dissolved by itself. Right? That's what she answered, and that's what happens also. If we do not even stir the sugar, if we are putting in water and we leave it for some time, the sugar particles will take some time to break down, and once they break down, they will eventually dissolve by themselves. So, and after some time of keeping the sugar in water, if we try to taste it, we are able to observe the nature of the water in the water. Why? Because we saw that the sugar particles broke down and they started to move, and they occupied the spaces which were present in the water. Clear, everyone? Another important example I'll give you to get it related to your everyday life. If you put some perfume, what are we going to observe? I mean, not us. If somebody is just sitting besides me and I put some perfume, will he or she be able to feel or smell the perfume which I have applied?
Yes, ma'am.
Yes, ma'am.
So, how come? I have applied and he or she can smell it. So, that means the particles of the perfume, the smell of the perfume, they travel to the other person. The particles were moving, only then the other person was able to feel them. Right?
Yes, ma'am. Ma'am, this property characteristic will apply to solids also.
Yes, this is applicable to solids also, but not to an extent like liquid and the gases. But how come in the solids the particles are seen to be moving? If we consider about the sugar particles, what are sugar particles in nature? They are solids only. They are breaking down, and both water and sugar that's the third property, what I'm just saying, they tend to attract each other. So when they attract each other, both the particles move a little, and the movement basically happens from a region of higher concentration to a region of lower concentration. Fine, we are going to discuss about it a little later because I have to give you a few more terms related to this. Fine. So I'll give you a small homework on the uh, WhatsApp group only. What is the homework is that you will be revising the characteristics of particles of matter and characteristics of matter only. Fine. And then we will be meeting again on Wednesday, and then we are going to see the video of the second property and we will move further with the chapter. Fine. I hope
Yes, ma'am.
everything was clear today.
Yes, ma'am.
Yes, ma'am.
Have a good day, everyone. Bye, and do revise the topics.
Bye.
Thank you,
Thank you,
ma'am.
everyone. Have a good day.
Thank you, ma'am.
Bye.